Welcome to Brain Vision.
Continuing on with our physical chemistry work. So we have the reaction in the vapor phase of water and sulfur trioxide to form sulfuric acid. So we can calculate the mass of SO3, that is our acid. So that would be equal to the mass of H2SO4 divided by the molecular weight of H2SO4 multiplied by S of SO3 divided by the S of H2SO4, multiply that by the molecular weight of SO3, where S is just equal to 1 mole. Plug in our values, we get 69.4 kilograms. So then we can add this mass to the mass of dissolved sulfur trioxide and divide by the total mass of the solution to obtain the mass percent of sulfur trioxide. So we have X SO3, that's equal to 69.4 kilograms that we just calculated. Add 15 kilograms divided by 100 kilograms, multiplied by 100 to get that in percentage form, we get 84.4%. Moving on to part B, so the partial pressure of the sulfur trioxide in equilibrium with the oleum is 1.15 millimeters of mercury. So the outlet gas is the equilibrium at 1 atmosphere, and the mole fraction of sulfur trioxide is as follows. So we have gamma SO3 out. That's equal to the partial pressure of SO3 divided by the total pressure. So we have 1.15 millimeters of mercury divided by 760 millimeters of mercury divided by 1 atmosphere multiplied by 1 atmosphere. So what we get is 1.51 times 10 to the minus 3 moles of SO2 divided by moles. So we can assume on the basis that we have 100 kilograms of this 98% weight of sulfuric acid solution, 2% water. So we can calculate the amount of 15% oleum generated using our water amount and the weight fraction that we've already calculated. So we have M of oleum is the mass of H2O is the acid as the mass of H2O of the solvent divided by X H2O of the oleum. So we can gather that by using this value here. 1 subtract this value would give us what we need. So what we generate is 128.2 kilograms. So the mass of the sulfur trioxide that needs to be fed into the gas phase is the mass of oleum minus the mass of the acid. So what we can have is SO3 in the gas phase is MSO3 oleum, subtract MSO3 of the acid, so we get 28.2 kilograms. And then with the mass of the sulfur trioxide, calculate the volume of the gas that is to be fed into the reactor. So we have V gas is equal to N gas RT over P. What we get is a volume of 8.379 meters cubed. Then we can obtain the ratio of the volume of gas fed to the mass of liquid fed. So we have R feed equals V gas divided by M liquid is equal to 0.08379 meters cubed per kilogram.